Hi guys, this is Mrs. Foy, and this is a tutorial about how to factor label. So factor labeling, or sometimes it's called dimensional analysis, is probably one of the most important things I can teach you how to do in chemistry. You're going to be using this problem-solving strategy for almost every math problem that you could use in chemistry and physics. It's super duper important. And I'm going to start out with some easy examples, and you might be thinking, "Ugh, I don't have to do this way. I know my way." Um, but pretty soon the problems get really hard and then you'll be lost. Okay. So I'm going to be a mean teacher and require you to do this method. And then hopefully you'll learn a new skill, and that'll be important. So let's get started. So you probably have used the word factor in math, right? So when you factor something in math, like you factor out this x plus 1 on the top and the bottom, it means to simplify things, right? So if you have x plus 1 on the top and x plus 1 on the bottom, you know x plus 1 divided by x plus 1 is 1, right? That's why you factor it out. And then you get 6 divided by 3, and that answer is 2. So think of factor labeling as a similar kind of thing. It's going to simplify things for you. So just like in factoring in math, I want you to see that all of these fractions that we have all equal 1, right? So this equals 1, and this equals 1, and this equals 1. And you're like, Mrs. Foy, yes, I know this, right? And so what you're basically saying is the thing on the top of the fraction, if it's equal to the thing on the bottom, then it's 1. But guess what, guys? This is also equal to 1, right? Because 1 mile is equal to 5,280 feet. And because this thing is an equivalence, what is on the top is equal to what is on the bottom, then technically it's equal to 1. And because of that, we can do some pretty cool things in factor labeling problem solving. So an equivalence is just a fancy way of saying something equals to something else. Okay, so we just said 1 mile is equal to 5,280. This is an equivalence. This is an equivalence, okay? And so from that equivalence, I can make 2 conversion factors. I can put 1 mile on the top and 5,280 feet on the bottom, or I can put 5,280 feet on the top and 1 mile on the bottom. It doesn't matter. I can flip these, right? I can flip these conversion factors, but they're both equal to 1. And so I want you to begin to see that every time you have something equal to something else, you can make a conversion factor out of it. And that's what we're going to use to do some pretty powerful problem solving in chemistry. So I'm going to show you how you can use any equivalence into a factor label method. Okay, so again, I'm going to start easy, and you're going to say, Mrs. Foy, I have an easier way of doing this. I'm sure you do, but I'm trying to teach you a problem-solving strategy that is going to be so helpful for you. So I hope that you trust me and just go with this, okay? So here we go. How many meters are in 2.4 kilometers? Well, I know that 1 kilometer is equal to 1,000 meters. From that equivalence, I can make 2 conversion factors. I can make 1 kilometer over 1,000 meters or 1,000 meters over 1 kilometer. But in factor labeling, what we're factoring, guys, is the unit. Okay? So I'm going to choose this conversion factor, because I want to cancel out the unit on the top and the bottom here, right? So just like you factor something in an algebra problem, in factor labeling, you're factoring out the unit, right? So here I'm going to put the 1 kilometer on the bottom of 1,000 meters on the top, because I can cancel out kilometers. Notice that I'm not touching the number. I am just crossing out the unit. I'm factoring out the unit. What do I have left? Well, I have left meters, and that's what I want. I want meters. So I'm done. All I have to do is just some easy math, and I'm just going to take 2.4 times 1,000, which is 2,400 meters. Unit. Whoops, sorry about that. All right, again, another very simple problem. And I know what you're thinking. You're thinking, I don't have to do this factor label stuff. I know how to do it in my head. Trust me. Pretty soon you're going to get two problems that you cannot just do in your head. And so I'm teaching you a skill. Okay, I'm teaching you a skill. So how many minutes are in 2.5 hours? Well, I know what's my equivalence. 60 minutes is equal to 1 hour. And from that equivalence, I can make two conversion factors. I can put 60 minutes is equal to 1 hour, or I can put 1 hour is equal to 60 minutes. How do I know which conversion factor to choose? I choose the one that's going to help me to factor out the unit. So I start with 2.5 hours. If I choose this conversion factor, then I can cancel out hours. I don't cancel out the numbers, guys. I'm just factoring out the unit. So I have the hours canceled. I have minutes left, which is what I want. And now I just do my math. The number 2.5 and 60, I did not cancel out. I was just factoring out the units. Okay? And so 2.5 times 60 is 150 minutes. All right, so this is a super great rule that I'm going to teach you about factor labeling, and I think you should like make a tattoo or something for it because it's super important, okay? If you want a single unit answer, you start with the single unit. If you want a double unit answer, you start with a double unit. All right, so tuck that away in the back of your head or write it down on a sticky note someplace because that's going to become really important for us in solving these problems all year long. But don't worry, I'll keep reminding you. All right, here we go. We're going to start with the English system, and we're going to start with time because for some reason this seems easy to students. So cool, we'll start with time. The problem is how many seconds are in 125 days? So I want seconds. That's a single unit. So if I want a single unit, I start with a single unit. I write 1.25 days. And then look at these, guys. Each one of these is a conversion factor that is equal to 1. Is 24 hours equal to 1 day? Yes. Is 60 minutes equal to 1 hour? Yes. Is 60 seconds equal to 1 minute? Yes. But look at the strategy that I used in how to set up my conversion factors. I want days to factor out or cancel out. So I'm going to put the 1 day on the bottom so my days cross out. Now I'm at hours. Now I'm going to use this conversion factor. 60 minutes is equal to 1 hour. I could flip it if I need to, but why do I not want to? Because I want to factor out hour. Okay, so I get to cross out hour on the top and the bottom. See how it's diagonally? One on the top and one on the bottom of those fractional conversion factors. Now I'm at minutes. I'm not done yet because I want to get to seconds. So 60 seconds is equal to 1 minute, and I can cross out my minute, and I have seconds left. How do I know I'm done? Because I have the unit that I want. Now I'm finished. And all I have to do now is super easy math. Now I care about the numbers, guys. I've crossed out all my units except the unit that I want, which is seconds. So now I'm going to take 1.25 times 24 times 60 times 60, and then I'm going to divide by 1 times 1 times 1. And that equals about 180,000 seconds. All right, so now let's try this one. How many milligrams are in 25 pounds? Now the directions say put the number in scientific notation with the correct sig figs, okay? So here are the equivalences I need. I know there's 1,000 milligrams in a gram, and there are 454 grams in a pound. So one thing that I will tell you right now in my class, I will always give you all metric to English conversions. Okay, so you are not going to have to memorize metric to English conversions. I am going to make you learn the metric conversions, but those should be easy for you. Okay, so do I want a single unit? Yes, I do. I want milligrams. So if I want a single unit, I'm going to start with a single unit, 25 pounds. All right, so now I'm just going to use these equivalences that I had up here, and I'm going to build my problem just kind of like Legos. I'm going to make some conversion factors down here so that the unit that I want to get rid of is always on the bottom, right? So pounds cancels with pounds. Does 454 grams equal 1 pound? Yes. And so my pounds cancel. Now I'm at grams. I want to get rid of grams and get to milligrams. So I'm going to use this conversion factor with grams on the bottom and milligrams on the top. Check. Does 1,000 milligrams equal 1 gram? Yes, it does. And so the 1 gram is on the bottom, so then I cancel out my grams. Notice I am not crossing out any numbers, guys. I'm just factoring out the units. That's why we call it factor labeling. So now I have milligrams left, which is what I want. So I'm done. All I have to do now is just some really easy math. So I'm going to multiply the top of my fractions. You know how to do this. 25 times 454 times 1,000 divided by 1. So that is 11,350,000 milligrams over 1. And because it says I have to put it in scientific notation with correct sig figs, I have to use those skills. All right, how many sig figs are in 25? Well, it's 2 sig figs, right? And so I'm going to put this number in scientific notation. So I'm going to go 1, 2, 3, 4, 5, 6, 7. So that's 1.135 times 10 to the 7. And then I'm going to round it right here because I'm only allowed to have 2 sig figs, and that ends up being 1.1 times 10 to the 7th milligrams. Don't forget your units. Okay, well, guess what? In chemistry, we get kind of lazy. We want some shortcuts. And so I'm going to want to show you this, okay? So here's a factor labeling problem right here. And a lot of times, some teachers teach you to put a 1 under here. I usually don't do that. I usually just leave the number with nothing under there just so that you assume there's a 1. But I see that you understand that this is a factor label problem. And this is actually a little beyond what we're doing right now, but you can still see that it's going to work. Grams, moles, you don't even know what that is yet. Moles of C6H12O6, moles of CO2. Again, don't worry about that right now. We're going to be doing this soon, but I just want to show you that that's a factor label problem. But we use these things called monkey bars that are just kind of a bracket kind of things. And do you see that writing it this way is the same thing as writing it this way? This is just easier, okay? So it means the same thing. Each of these boxes is the fraction, okay? So it's just showing us this is the top of the fraction and this is the bottom. And it's just a little bit easier that way. To write it. If you want to write it this way, go ahead. If you want to write it the long way, that's fine. But if you want to use these little monkey bar things, that would be fine as well. All right. This is importante, folks. This is a very important equivalence in chemistry that we use all the time. It's just like 1 minute is equal to 60 seconds, okay? But this freaks people out because it's a really big number and it's a unit they've never heard of before. So there's something in chemistry called a mole. And a mole is not a little furry brown thing that digs in your yard. It's actually kind of like a dozen, okay? Except instead of having 12 things in a dozen, a mole has this ridiculously big number. Okay, 1 mole is equal to 6.02 times 10 to the 23 things. And the things that we're counting in chemistry are usually atoms, molecules, or ions. So even though I'm going to teach you a lot more about a mole and what a mole is, right now you don't even need to know that. Because hey, if it's an equivalence, you can do a factor label problem with it. As long as you know something is equal to something, you can factor label. All right, so let's do a factor label problem here, okay? How many moles of gold are in 5.5 times 10 to the 24 atoms of gold, right? AU is gold. Put the answer in scientific notation with correct sig figs. So here's that really important equivalence. 1 mole is equal to 6.02 times 10 to the 23 things. And what we're counting in chemistry are atoms, molecules, and ions. In this case, the particle we're counting is an atom. Do I want a single unit? Yes. I want moles. And the abbreviation for moles is just MOL. Okay, it's not very much of an abbreviation, is it? But that's the abbreviation. So that's my single unit. If I want a single unit, I'm going to start with a single unit. And you can see I use the monkey bars here, just the quick little shortcut. So here's my equivalent. 1 mole is equal to 6.02 times 10 to the 23 atoms. But I want the atoms to be on the bottom here. So that's why I put 1 mole over 6.02 times 10 to the 23 atoms. Now I can cancel out atoms. And what do I have left? Moles. Well, that's what I want. So I'm done. I'm done with my problem. Now I have to use my math skills. 5.5 times 10 to the 24 divided by 6.02 times 10 to the 23. So 5.5 divided by 6.02 is 0.914. And then what do you do with exponents when you divide? You got it, you subtract, right? So this is 24 minus 23. And this, oh, I just see I made a mistake here. This is 10 to the 1, right? 24 minus 23 is 10 to the 1. So good, I'm so glad I made a mistake because then that helps us, that's going to help us here. All right, so I have to put the number in scientific notation. So I'm going to move this decimal over. I'm going to make this number bigger, right? If I make that number bigger by a factor of 1, I have to make this exponent smaller by a factor of 1 because it was 10 to the 1, and so I move this decimal to make it bigger, and I make this smaller by a factor of 1. So it's going to be 9.14 times 10 to the 0 moles. Well, you might remember that 10 to the 0 is 1. Okay, so I don't have to put that. I can just say 9.14 moles, and now I got to look at sig figs. How many sig figs are here? There's 2 sig figs. So that means I have to round this number to the correct sig figs, and so it's going to be 9.1 moles of gold. 9.1 moles of gold. All right? Per, meter. All right, so here we have a nice big juicy problem for us to start. Okay? So here we go. Convert 25 miles an hour, and this diagonal thing right here, guys, means this. It means 25 miles in 1 hour. That's what 25 miles an hour means. So that diagonal line means that. It's just a way we kind of write it. Okay? So what I want is meters per second. I want meters per second. So I want a double unit. All right? So remember what I said. If you want a double unit, you start with a double unit. So I got 25 miles in 1 hour. Over here is a shopping list of all the conversion factors I'm going to need. I can see that I'm going from an English system to a metric system, and I'm going from hours to seconds. That's actually easier, the time thing, so I'm just going to do that first. It doesn't matter if you convert hours to seconds first or if you convert miles to meters first. So I'm going to do the easy part first, okay? Now I want to get rid of hours, so I'm going to use this conversion factor, 1 hour over 60 minutes. Do you see why I put the hour on the top? Yep, because I want it to cancel out diagonally with the hour that I have on the bottom. Now I'm in minutes. I need to get to seconds. So I'm going to use this one. I'm going to say, well, in 1 minute, there are 60 seconds. So my minutes cancel, and I end up with seconds on the bottom. So I've already gotten the time to convert. Now I just have to get the miles to meters. All right? But I'm going to start with what I want. I'm going to use this one first. 1 mile is 5,280 feet. So my miles cancel. Now I'm at feet. So I'm going to say 12 feet are in 1 inch. Well, that's not right, is it? Oh, I'm so glad I made that mistake. So let's fix that. Let's fix that. All right. So in 1 foot, there are 12 inches, right? So my feet cancel, and now I'm at inches. So now I'm going to say, well, 1 inch is equal to 2.54 centimeters. Do you see where I'm getting this? I'm getting these conversion factors from the equivalence. And then I'm canceling out the units. Now I'm at centimeters. I have to get to meters. So I'm going to use this one. All right, so I'm going to say there are 100 centimeters in a meter. Okay, and my centimeters cancel. And look, that's a bad M. Sorry. I've got meters left. Do you see how I've canceled out everything but meters over seconds? So I'm done. I'm done. The hard part of the problem is done. So now what I'm going to do is I am just going to do my math, okay? So I'm going to say, what do I have on the top? So I have 25 times 5,280. I'm actually doing this right now. So 25, do it with me, times 5,280 times 12 times 2.54 times 1 divided by 60 divided by 60 divided by 100. All right? And I get 11.17 meters per second. Okay? So pause this video if you need to and check your math. Okay? So what did I have on the top? I had 25 times 5,280 times 12 times 254, that's all I had on the top, divided by 60, divided by 60, divided by 100. If you do that, you should get 11.17. Okay? So it says that I have to put my answer in scientific notation with the correct sig fig. So 11.17 meters per second. So I'm going to put that in scientific notation. 1.117 times 10 to the 1 meters per second. And now I'm going to do my sig figs. How many sig figs in 25? Remember, the equivalences have an infinite number of sig figs. So I don't look at those. I just look at this number. It's 25. So I have 2 sig figs. So I'm going to round off right here. And so my answer is 1.1 times 10 to the 1 meter per second. Okay? All right. So we're going to have a lot more practice with this. Don't worry if this seems overwhelming to you right now. We're going to keep practicing. All right? See you in class.